All right. Hello, Math Hustlers. This is Mr. Heath and the parents and guardian of Math Hustlers. This is Mr. Heath, and I'm going to go over the topics that we'll be covering this week in class. So two major topics that we'll be discussing, doing real world exercises with, doing computations with, and then eventually assessing this week are these here. First one, finding out if a table or chart is displaying or modeling a proportional relationship. And then when we're done with that one, we'll talk about if a graph of a line is displaying or modeling proportional relationship. So some of this language seems pretty technical and stuff like that, but you'll see what I mean in a moment. So beyond the technical language, let's go ahead and take a look at this one and model a challenge that your child will be seeing this week, or you'll be seeing this week if this is a student. So one of the challenges you'll be seeing this week is right here. It says a cran apple juice blend is mixed in a ratio of cranberry to apple of 3:5. Complete the table to show different amounts that are proportional. All right, so let's get a little background music here. Let's take a look at this challenge here. Some important things to see here. You don't really know what the influencer and the influencee is. So what you can use to help you out here is this idea, right? This right here. See where it says apple, ratio of cranberry to apples of 3:5. Okay, so the last digit whenever you are reading a ratio is always going to go in the denominator position. So see it that way. All right, and the first one is always going to be the numerator position. All right, and what did we say about in class? Parents, if you're watching this in class, we talked about the idea of the X and the Y. All right, so if I want to, I can put an X here and a Y here. All right, because remember it said the apple is 5. Okay, so the amount of apple in the first one, 5. All right, so 3:5. Okay, so the next one, it says it wants these to be an amount that's proportional. So what I'm going to do is I'm going to take the original one, I'm going to multiply this by 2. So 2 sets of 5, 10. 2 sets of 3, 6. I'm going to keep it proportional. Multiply again the original by 3. So 3 sets of 5, 15. The original ratio value here by 3, that's 9. So I have 1, 2, 3, just like the chart asked me to do. So it says, question says, why are these quantities proportional? So in class we talked about this idea that there's one way that we can figure out, well, excuse me, I shouldn't say there's one way. We really focused on one way today, but there's actually two important ways that you can, or major ways you can use to figure out if something's proportional. One way is to go ahead and find the quotient of each ratio. And if those quotients are all the same, then this table of values you have here is proportional. So let's take a look here. I have, all right, remembering the rule, x divided by y, excuse me, y divided by x. So we go over here, I have 10, 6. Remember the rule once again, y is going to be divided by x. I have, what is that, 9. Am I correct there? Yeah, so that's y. And we have 15 here. All right, so let's go ahead and find the quotient of these. So I'm going to erase this here. And I have 3 divided by 5. All right, so A. Go over here. Let's go ahead and do the math on the side. Do a little wind up, as we say, Tiger Woods. So we'll go ahead and do this one. So I asked myself, how many sets of 5 are in 3? Oh, there are none. I'm going to get a decimal point, then place a 0. The decimal point just let me know it's going to be less than 1. Whatever my quotient is going to be less than 1. So I ask myself, how many sets of 5 are there in 30? There are 6. 6 sets of 5, 30. So far I'm looking at 6/10 for this ratio here. So let me erase this. Actually, let me keep this here. And let's talk about the next one. 6/10. If you're good at simplifying, you may have noticed something. If I go over here and divide this by 2, and this by 2, which we call simplifying, then guess what? I get this original 3/5. Let's talk about why that's so. If you look at 6, 6 is really the product of 3 and 2. If you look at 10, 10 is really the product of 5 and 2. You'll notice that they share this, what we call multiple or number in common. So we get rid of that, we have 3 over 5. So I'm just doing the same thing over here just by dividing that. So if I notice it's 3 over 5, what's the quotient going to be? 6/10. If you'll notice once again at the 15 and the 9, divide by 3, divide by 3. I've got 3 over 5 once again, and I know it's going to be 6/10. So let's say you're not really good at simplifying yet. You don't know how to use the number circles. So let's go over here and take a look at how we would do it next one then. All right. So we have 10 divided into 6. Okay. Go over here, do my math. 10 here, 6 there. How many sets of 10 are there in 6? There are none. A decimal point, smallest digit 0. I'm going to bring that up. That just lets me know that my quotient is going to be less than 1. How many sets of 10 are there in 6? Excuse me, are there in 60? There are 6. 6 sets of 10, 60. The result, 6/10. Either way, I'm getting the same 6/10. Let's look at 15 divided into 9. So we'll go over here. I'm going to erase this. All right, 15 divided into 9. Let's say I didn't know how to simplify it. So I'd go here, 15, give myself a little more space. 15 divided into 9. Ask myself this question. How many sets of 15 are there in 9? Well, there are none. Once again, like a robot, put a decimal point, place a 0. Bring up that decimal point. That decimal point should let me know that my value is going to be less than 1. How many sets of 15 are there in 9? None. How many sets are there in 90? I'm going to say 6. But I don't know. Let's see. So I have 15 times 6, 5 sets of 6, 30. Carry that. 1 set of 6 is 6 plus 3 is 9. I'm looking sharp. Once again, we get the same value there. So here's the rule. As we look at this one, the reason why I know this is proportional is because every single quotient of these ratios is the same. 6/10, 6/10, 6/10. Now, how does that matter in real life, and why would I care about this? So let's say that you're making these drinks for some place, right? Some kind of cran apple and cranberry juice mix. All of a sudden, someone goes and and puts that in. 16 to 20. Well, let's simplify that. So, and I have 16 divided by 4, divided by 4. I have 4/5. Well, if I divide 4/5 into that, let's see, 5 into 4. Decimal point 0, like we've been doing. Rewind if you're confused. Bring this up. We find that's 8. Well, we can see that 8/10 is not the same as 6/10, 6/10, and 6/10. And thus, we know this is not proportional. What does that mean in real life? This drink is going to be a bit more cranberry-ish in a sense, and not the same. I shouldn't say as much cranberry-ish, but it's going to be a little bit more, yeah, cranberry-ish than the other drinks are. Why? Because a larger amount being placed into there. Okay, so that's really important that we understand that this is going to change the flavor and taste of this if this drink is no longer proportional, as you saw right here. So that's sort of the real-world applications of it. Now, I'm going to go ahead, take this, and apply these values that we see right here to deal with our next situation. And that was to tell how a graph of a line is displaying or modeling a proportional relationship. Now, we've seen from a table or chart how we can find out if it's displaying a proportional relationship. If all the quotients are the same. Another way is also if you were to multiply each value by the original value by the same number. So know how I multiply the original value here by 1, I have that one. I multiply the original value by 2, get that value. I multiply the original value by 3, get that value. And we'll talk further about that one. But big idea is finding these quotients. You notice here this quotient of this ratio wasn't the same as these. Therefore, this table is no longer what we call proportional. And in the real world, your drink is going to taste a bit more cranberry than apple. All right, so now let's go ahead and take a look at what happens to this data here and see what it would look like if it was proportional being placed on a coordinate plane or quadrant. So let's move this aside. I'm going to bring this piece of paper here. Let me erase this. Alright, so I have this quadrant here. What I'm going to do with this quadrant is, remember we said X and Y. So I'm going to put for X, amount of what? Apple. For my Y, amount of what? My cranberry. So my X, my amount of, oops, I'm sorry. My X, my amount of apple. My Y, my amount of cranberry. So see it right there. So now I'm going to go ahead and lay out my numbers. 0, 0. This is called the point of origin. And I'm going to do the X in increments of 5. It makes sense to do increments of 5 here because you can see 5, 10, 15. So we go here. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and we could keep on going, but we're going to stop there. Well, on my y-axis, what increment should I be going? I think an idea. 3, 6, 9. So let's go ahead and run that pattern. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So I'm going to go ahead and plot these points onto the graph here. So I'm going to go to 5 on my X and then go up to 3 on my Y. All right, 0, 5, and 3 on the Y. So that point is done, line through it. Let's go to the next one. Go to 10 on my X and 6 on my Y. All right. And notice every time I'm starting at 0, 0, 5, 10, and it's at 6. 3, 6, right there. All right. So now let's go to the next one here. Let me put a line through that. I go to 15 on my X and 9 on my Y. All right. Going back to the point of origin. 0, 5, 10, 15. All right. And then 9 on my Y. 3, 6, 9. So now the rule is that if I have a line that grows straight and it goes to the point of origin, that line is modeling a proportional relationship. So let's see. All right. Well, it's going to the point of origin and the line's going straight. Guess what? The first part of this, not this part, is definitely a proportional relationship. We know that from looking at the chart or table of values here. And look what we did when we graphed those points. It made a straight line that if I was starting out at 0, would go through 0 and keep going straight. Now let's look and see about a line that models a non-proportional relationship. Let's go and take this point here. So we'll go 20, 16. So 20, 16. So 0, 5, 10, 15, 20, 3, 6, 9, 12, 16. Now notice what happens to my line. It goes this way. It goes this way like this and then up. And then maybe it goes back that way again, who knows. But notice, it's going to the point of origin to start with, but then it starts going crazy like this. It doesn't continue straight. That is non-proportional. So notice the straight line from the first values here, that represents a line that is representing proportional relationship. Notice when I put the second value here, that also made this table of values not proportional. Notice where the point went up here, my line stopped going straight and went straight up. That is a non-proportional line right there, or a line that's representing a non-proportional relationship. So I hope this really helps you out this week. Refer to this, parents, if you need to refer to this to help your child sort of understand the math a little better. And that is it. I hope it helps.